Good morning, everyone.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Good morning. Good morning.
Good morning, sir.
Can you see my slides?
Yes, sir.
Yes, sir.
Okay. Yesterday, I discussed about the different system architecture models in distributed computing system. As I discussed, there are two types of architecture models in distributed computing system. That is the client-server model and the peer-to-peer model. So in the client-server model, we have a client which uh, which wants some services from the server. So it requests its services from the server. The server processes those requests and sends its response to the clients. And we also saw the peer-to-peer process. In peer-to-peer process, we saw that every system have the same functionality. Every devices have the same functionality. There is no client, there is no server. Both can act as a client as well as a server. After that, I discussed about the different variation of client and server. First variation we saw the proxy server and cache. And next we saw that there are different variations like mobile code, mobile agents. So in continuation of the variation of client server, as you can see that a client requests a code, applet code from the web server. So web server sends the applet code to the client. After getting the applet code, the client executes the applet and it interacts with the applet itself instead of directly contacting the web server, and thereby minimizing the workload on web server. It is working on the applet which it has installed in its system. So now the client is interacting with the applet. It sends its request or it wants some service from the applet, and the applet will process the service and give the response to the client. So this is the working. This was the one of the variation of client server model. Now today I will discuss about two other variation, that is network computers and the thin clients. So what are network computers? The network computer was a diskless desktop computer device made by Oracle Corporation from about 1996 to 2000. Yani diskless means it did not have any memory devices. It did not have any inbuilt memory devices. For example, hard disk, etc. So the devices were designed and manufactured by an alliance which included Sun Microsystem, IBM, and others. So these devices were made by Oracle, but Oracle also cooperated with itself different companies like Sun Microsystem, IBM. The devices were designed with minimum specification based on the network computer reference profile. The brand was also employed as a marketing term to try to popularize this design of computers within enterprise and among the customers. So basically, network computers were those devices which were very light, means they did not have any software installed on their own. They had to depend on a main computer for their uh, for their working. The NC brand was mainly intended to inspire a range of desktop computers from various suppliers that, by virtue of their diskless design and use of inexpensive component and software, were cheaper and easier to manage than the standard fat client desktops. Means what? These computers, the network computers, were very cheaper compared to the desktop computers, because desktop computers needed various type of components like memory devices and many other configuration which were not required in the network computers. Network computers were just a computer that was mainly used as a client computer. It was only used for interacting with the server computers. The computer server computer had all the software, all the applications in that in itself. The network computer would only was only used for interacting with the server. For example, we have the N computing in our server room. So the N computing is a type of thin client. It's not a network computer, but it is a type of thin client. But you can get an idea about what a network computers means. Network computers are mainly used, for example, when we are in a classroom. Classroom we have different computers and we have a projector. Okay, so that computer is mainly used for displaying purposes. If that computers are connected to the projector main computer which will display the presentation on the computer, so that was network computers which was used for particular process or for particular purpose. So however, due to the commoditization of standard desktop components and due to increasing availability and popularity of various software options for using full desktops such as diskless nodes, thin client, and hybrid client, the network computer brand never achieved the popularity hoped for by Oracle and was eventually mothballed. Means it was scrapped because as day by day, as the desktop computers and as the desktop computers got cheaper and cheaper, and due to the introduction of thin clients and hybrid clients, their popularity got decreased day by day, and after that it was erased. So the network computer eliminate the need for storing the operating system and application software on desktop PCs, and instead download this from a remote file server. So instead of uh, storing the operating system itself, we are directly connecting with the main computer. Applications are run locally, but the files are managed by a remote file server. We have some lightweight application, but the main work is handled by the remote file server. Since all the application data and code is stored by a file server, users may migrate from one network computer to another. The processor and memory capacities of a network computer can be constrained in order to reduce its cost. Means we can have a light processor and even a light memory capacity in a network computer. It does not need a heavy processor. If a disk is provided, it holds only a minimum of software. Means suppose at that time when the network computers were made, at that time there were floppy disk and compact disks. So we can have a floppy disk which contained a minimum of software, and a network computer could run those software and do its work. The remainder of the disk is used as a cache storage, holding copies of software and data files recently downloaded from the server. So this was about the concept of network clients. network computers. Any questions? So we'll start with a thin client. In network computing, a thin client is a simple, low performance computer that has been optimized for establishing a remote connection with server based computing environment. Means it is just as a network computer. Means it is mainly used for to act as a client. It does not have its own software, just as network computers. The server does most of the work, which can include launching software programs, performing calculation, and storing the data. Means the server is handling all the processes. It has all the operating system, the main operating system, the applications, various application, and it all the components, hardware devices, processor. It's very powerful. The memory devices are very large. Hard disk has more capacity. This contrasts with the flat client or a conventional personal computer. The former is also intended for working in a client-server model, but has significant local processing power, while the latter aims to perform its function most locally. See, the fat clients means the normal desktop computers, which has every component, memory devices, processors, CPUs. So, network, this is compared to the main server, it has less memory power, but it has all the components. Thin client occur as components of a broader computing infrastructure where many clients share their computation with a server or server farm. Means, as I've given an example of n computing devices in our server room, in a server lab, thin clients are just a component, are just devices where we have many thin compute clients that are interacting with the main server. The server side infrastructure uses cloud computing software such as application virtualization, hosted shared desktop, or desktop virtualization. This combination forms what is known as a cloud-based system where desktop resources are centralized at one or more data centers. The benefits of centralization are hardware resource optimization, reduced software maintenance, and improved security. As uh, in a centralized system, what happens that a single system has all the software features, all the hardware features, it has all the security features in it, installed in it. Instead of installing security features in all the thin clients, the main server has all the security features. So the cost is decreased in using the thin clients because the hardware cost decreases. Thin client refers to a layer of software that supports a window-based graphical user interface on the local computer while executing application programs on a remote computer. Just as in our end computing devices, it can be used for only display purpose. Uh, Person gives his presentation, and that presentation is displayed on the system. This architecture has the same low maintenance, management, and hardware cost as the network computer, but instead of downloading application code into the user's computer. It runs them on a compute server, that is a powerful computer, typically a multiprocessor or a cluster computer that has the processing power to run several applications concurrently. What is the drawback of using thin client and network client is that highly interactive graphical apps like CAD and in image processing will incur both network and operating system latencies. Now, if we want to run the heavy application CAD and image processing, okay, if all the client want to use the apps such as CAD and image processing, then it will create a network workload on the server, and server will be it will where the server process will become slow because these are heavy application and needs a heavy bandwidth. So this was the drawback. So example is the Citrix WinFrame product that provides a thin client process providing access to apps running in WinNT host. So as you can see, we have a network computer or PC, or network computer or a thin client. They are connected on a network and they are using the network. They are connected to the main server, that is the compute server, and in the server itself there is an application process, the application that a client use for doing its work, means it is connecting with the server for doing its or own work. So these were the different variation of client and server models. Next topic is the fundamental model. So a fundamental model of a distributed system defines the way in which the component of the system interact with each other and the way in which they are mapped onto an underlying network of computers. What does it mean? Means that if you take an example, if you take any architecture consists of different components. So in a fundamental model, we try to understand the different functionalities of those components, how they behave, how they interact with each other, and what is their purpose is done by the fundamental models. Example include the client server model and the peer process model. As we have seen that we have two architectural model in distributed computing system, the client server model and the peer process model. So in these models, the client and server model and the peer process model, how the components interact with each other, what are the components, what are the functionalities of each component will be studied in the fundamental models. The client server model can be modified by the partition of data or application at cooperating servers, the caching of data by proxy server and the client, the use of mobile code and mobile agents, example, applets and object serialization. Means we have taken in this example, we have taken the client server model. In the client server model, we have seen that the functionality is divided into a client and a server. How those client and server function, how they perform, and then we saw that the different proxy server in the clients, the use of mobile code and mobile agents. What is the purpose of mobile code? What is the purpose of mobile agents? How they interact, how they will interact, what is their functionality will be handled by the fundamental models. So there is no, as we know that there is no global time in a distributed system. So all the communication is achieved by message passing. See, in a distributed computing system, we interact by passing our messages. The messages contain information. Those information contains the services that our client wants or the services that a server sends. This is subject to delays, failures of various kinds on the network, and security attacks. These issues are addressed by the three models. So while passing the messages, if in a distributed system, as we pass the messages, the message is prone to delays, failures of various kind, and security attacks. So these issues are understood by these three models. What are the model? The interaction model, the failure model, and the security model. So in this the interaction model deals with the performance and with the difficulty in setting time limits in a distributed system. For example, message delivery. So in the interaction model, we discuss the issues of how much time a message takes to reach its destination, how much time the destination sends its reply, what is the performance of the system, etc. These are all dealt in interaction model. The failure model attempts to give precise definition for the various faults exhibited by the processes and the networks. So in the failure model, we try to understand what type of failure can come while passing our messages. So which are those failure types will be discussed in the failure model. And the security model. The security model discusses possible threats to processes and networks. For example, there can be a DOS attack, denial of service attack. Okay, so those type of threat can be internal as well as external threats, which can be done in a network. Models used to characterize distributed systems. A model of a system determines the main entities of the system and describes how they interact with each other. The purpose of a model is to make explicit all the underlying assumption about the system being modeled. There are three kinds of models used to describe distributed system: the interaction model, the failure model, and the security model. So first we discuss the interaction model. What is the interaction model? What does it handles? Processes in a distributed system, that is client side and server side processes, interact with each other by passing messages. As I said that in a distributed computing system, different devices interact with each other by passing messages, resulting in communication, that is message passing, and coordination, synchronization, and ordering of activities. How can we synchronize? Okay, so for example, I want to transfer my money to someone else. So first my account will be debited, and that will be reflected in my friend account. So we need to synchronize those activities. Each process has its own state. As we know the process cycle, in the process cycle, first the process is created, then it is executed, and then it's the a process is created and it is executing, and after that it will be executed or it will be aborted. So a process have different type of states. There are two significant factors affecting process interaction in a distributed system. communication performance is often a limiting characteristics. See, as we are dealing with the uh, networks have limitation on the bandwidth. How much bandwidth, how much messages can that medium handle? Medium, the bandwidth will directly affect the communication performance. If we are passing so much messages that the medium cannot handle, then the performance of the medium will decrease. There is no single global notion of time since clocks on different computers tend to drift. Means what? See, different systems are on different locations. We have different time zones. On different time zones, we cannot set a particular time. That we cannot say that when I'm sending my message at 9:46, the time is showing on a USA system is also 9:46. So there is no global notion of time since clocks on different computers tend to drift. Now in the interaction model, we discuss about the performance of communication channels. How do we measure the performance of a communication channels? So for that, we have three parameters: latency, bandwidth, and jitter. Communication of a computer network has the following performance characteristics relating to latency, bandwidth, and jitter. So what is latency? Latency means delay. It is also called as delay. The delay between sending of a message by one process and its receipt by another is referred to as latency. Means how much time a message takes to reach its destination is called latency. The latency includes the propagation delay through the media, the frame or message transmission time, and the time taken by the operating system communication services. Example, TCP or IP stack at both the sending and receiving processes, which varies according to the current load on the operating system. How much time a system takes to send the messages? How much time a medium takes to send that message and to um, to send the message to the destination, and how much time a destination takes to receive the message is known as latency. The bandwidth of a computer network is the total time of the information that can be transmitted over it in a given time. So it is the amount of information. Bandwidth is measured in bits per second, kilobytes per second, bytes per second. Means how much amount of data can be sent per time is called a bandwidth. Every medium has a limited bandwidth. Only it can handle that bandwidth only. If we try to send more messages, then it will affect the performance of that medium. Next is the jitter. Jitter is the variation in the time taken to deliver a series of messages. This is relevant to real-time and multimedia traffic. See, difference between jitter and delay. Delay handles is related to a single message, whereas jitter deals with a series of messages. For example, if a sender is sending 100 messages, okay, so what is the variation of those messages? How much time those messages, what is the variation of those messages in receiving, that is being received by the receiver? That is the, it calculates the variation, how much all the messages takes to reach the destination. So jitter deals with a series of messages, whereas a delay handles is dealing with a single message. So these were the different performance characteristics of a medium communication channel. Next, we have two variation of interaction model. The two variation of the interaction model are the synchronized distributed system and the asynchronous distributed system models. So there are two variation of interaction model. The synchronous distributed systems are defined to be systems in which the time to execute each step of a process has a known lower and upper bound. Each transmitted message is received within a known bounded time. Each process has a local clock whose drift time from real time has a known bound. It is difficult to arrive at realistic values and to provide guarantees of the chosen values. Means what? In synchronized distributed system, we know how much time a message will take to reach its destination. How much time a sender will take to send a message, and how much time a receiver will take to process those messages. So we know beforehand that how much what is the time taken for all the processes to complete. In a synchronous distributed time, we know that this will take so much time, but in asynchronous distributed system have no bounds on the process execution speed, message transmission delays, and clock drift rates. Means what? In asynchronous, we do not know how much time will a sender take to send a message, how much time the message will take to reach its destination, and how much time a processor or a receiver will take to process that message and reply back. This exactly models the internet, in which there is no intrinsic bound on the server or workload on the network load, and therefore on how long it takes, for example, to transfer a file using FTP. Actual distributed system tend to be asynchronous in nature. So internet is an example of asynchronous distributed system. In internet we do not know how much time will our mail take to reach the destination. Okay, so where there is no time boundation, where we do not know beforehand what the time, how much time will it take, those are called asynchronous distributed systems. So this was about the interaction model. Okay, so any question?
एक्सक्यूज मी सर
Yes.
सर ओरेकल कनेक्शन क्या होता है?